In this program, we will look at just the minimum amount of code that you would need in order to create a two-dimensional array. In the previous example, I went behind the scenes a little bit and gave you some of the detail about what was really going on. But if you're just writing the code, then here is all you really need to do to make a two-dimensional array. I'm using the Initialize Dynamic, and I called it Initialize 2D last time, I think, in the previous example. But I have a function that will initialize a dynamic two-dimensional array and another one called print array dynamic that will print out the values. And you can see we're using the double star notation here. If we scroll down to the functions, then here they are. This is just an ordinary loop that goes through and uses the regular square brackets to initialize the array to some random values between 0 and 99. But the notation is what's important. If you're going to use a two-dimensional dynamic array, then this is what your formal argument has to look like. The advantage of this is that now you can use this function, which is initialize dynamic, the same thing for print array dynamic, and you can pass in any array, any two-dimensional array with any number of rows and any number of columns, and it will work. Now, let's go back up to the main program, and let's start out by initializing, we're declaring a variable for a very specific array, numbers with 4 rows and 10 columns. It's an unsigned int, and I'm calling it numbers. But if I want to use it as a dynamic array, I need to precede it with the double asterisk notation here. Then, if I want to create this array with 4 rows and 10 columns, the first thing I will do is, like I did previously with table, is I want to generate a one-dimensional array that has 4 rows. So to do that, I will set numbers equal to a new unsigned integer, and I want to give it 4 columns. I'm sorry, 4 rows. But since this is a dynamic two-dimensional array, this table of numbers, it has to be a pointer to an unsigned int. That's really the important syntax we have here. So we have to make that a pointer to an unsigned integer. Now that that's done, we can generate 4 one-dimensional arrays, and we will save their addresses into that index, the first index, the row index of numbers. In the previous example, I declared 4 separate one-dimensional arrays, and then I copied in their addresses. But you don't have to do it that way, and normally you wouldn't. So we'll just use a for loop. For k equals 0, k less than 4, in this case, k plus plus, we will generate a one-dimensional array for each of these 4 elements. So that's pretty easy to do. Numbers, bracket k, is equal to a new unsigned int, and we have 10 of those, 10 columns, then semicolon. So that's it. These 3 lines here, plus the declaration up there, that's all you really need to make a dynamic two-dimensional array. I could have declared numbers just to be 4 by 10, but if I had done it the old-fashioned way, then I couldn't call the functions that I've declared down here. So you have to decide, do you want dynamic arrays or do you want static arrays? Now, I already have the calls to initialize and print my 2D array numbers. So I call these two with the variable numbers, the normal way that you would do it, and we have 4 rows, we have 10 columns. Okay, so the functions themselves are looking for number of rows and number of columns. So let's compile and run the program. Now we have the results. So you can see initialize and print the 2D array of numbers. We have the variable on the left, we have the contents on the right, and if you go through this, you'll see that we have the first row index 0, 1, 2, 3, so that's 4 rows, and each row has 10 numbers. So that was pretty easy. We've generated now a dynamic two-dimensional array with 4 rows, 10 columns. We've initialized them and just printed out the results. So the main point of this is to show how you call the functions and the technique that you have to use to make a two-dimensional array. Now, let's move on And let's let the user type in the number of rows and number of columns. So that will then allow the user to pick any sized array that they want to. So for this part, we just need to input the rows and columns. So we have the prompt and we have the cin statement to read those in. This one, I'm going to use the variable table like I did in the previous example. Unsigned int double star table. With a semicolon. And so that will declare it. And I can also, on the same line, I can go ahead and do the new operation up here. Okay, so previously I declared it and then I used new here. Well, we can combine those together in the same line. So I can declare the pointer and use the equals to a new unsigned int, which is a pointer to the an unsigned integer, and it's as big as the number of rows. Notice the difference, and also I insist on putting my pointers next to my variable. In this example up here, I had exactly 4 rows. I wanted an array that was 4 by 10. In this case, the user types in how many rows they want. So whatever the user wants, that's what the user will get. So that's the only difference between what we did above and what we're doing here. Now that we have the number of rows, we need to have a loop to generate a one-dimensional array for each row, and we can use our for loop for that. So same thing for k equals 0. This time we don't know how many the user wants, but we know that k is going to be less than that. That's where the index stops. K++. Then inside the loop we do the same thing we did above. So we have table bracket k is going to equal to a new unsigned integer. Okay, new unsigned int. And how many of them? How many elements in each one of our rows? Well, the user picked it. Columns and semicolon. There. So this is the same as the example I did above, and I've shortened it just a little bit further by just making those 3 rows. So yeah, you have to write a little bit more code if you want to make a dynamic 2-dimensional array, but it's worth it. I had used this, I had commented out this call previously because I had not declared table. So let's just uncomment these calls to initialize and print the array. So, and that will be the end of the program. So let's compile and run the program again. Here's the output. Here, this is the array numbers, which was 4 rows by 10. Now we're down here pressing the key to continue. So when I do that, then we're prompted to enter the number of rows and number of columns. All right, let's pick something not real big. Let's say 6 rows and 8 columns. And I press enter, and here we go. So I've generated now a dynamic 2-dimensional array. So it has 6 rows, so 0, 1, 2, 3, 4, 5 for the first index, and inside the number of elements per row, it's 0 through 7. So this is our 6 by 8 array. So this program illustrates that you can type in the number of rows and number of columns and generate a 2-dimensional dynamic array. And you can do it pretty simply by just looking at this example. You just have to know these 3 lines of code. So there they are. So in the future, if you aren't concerned about what's going on behind the scenes, then just remember that if you use these 3 lines of code, you can make a dynamic 2-dimensional array. One warning that I should give you here is that nothing is free. When you make a dynamic 2-dimensional array, one thing that you do not have is all of your numbers are not stored in consecutive locations in memory. So that's really important. Each row will be stored in consecutive locations, but because we are generating with this new statement, we're generating other one-dimensional arrays that have this many numbers, this columns, that's how many elements it'll have. But each one of these rows is going to be stored in a different location in memory. So if you had an application later on where you really needed all the values to be stored consecutively, then you could not use this dynamic 2D array approach. That's it. So now you have another tool that you can add, and then you'll be able to write functions that are no longer constrained by having to fit the number of columns whenever you call it. And that's the end of this video.